Okay.
Can we go? Is there an introduction, or we're good to go? All right. Good morning, everyone.
Good morning. Welcome, everybody. Thank you for coming.
Oh, kind of a dead crowd. Is everyone having a terrible day today?
Terrible day, Stephen. How could you have a terrible day?
I don't know. I'm not having the best of days today.
Man, sorry to hear that. Listen, not to brag, but I'm actually having a great day.
Really?
Yeah, let me tell you why. My Jenkins instance in AWS just hit the 1-year mark today. 1 year, full uptime, never restarted, never rebooted, solid 1 year.
Full 365 days up.
365, going for 366 tomorrow.
We got to check
Really
this
stoked.
out. Let's take a look here. Is this it right here?
Pretty basic, but yeah,
Okay.
that's it.
All right.
Yeah, pretty basic.
Nice. Well, let's take a look at the infrastructure. All right, I see you got an instance running here.
Yeah, oh yeah.
All right.
Yeah.
Very cool.
Yeah.
You do have instance protection, right, on your instance?
I mean, instance protection, I don't need it. I trust my team. Got a good set of guys at the office. I don't really foresee anything happening to it, so no, I don't see any need. You know, it's, again, 366. I'm really excited. 366 is a big number. I think it's going to be a big deal.
Was that PagerDuty?
What just happened?
You guys have all just witnessed a disaster that can ruin your day. So let's go back to this presentation. All right, so welcome, guys. This is creating a disaster-proof multi-environment Jenkins. And
Has this ever happened to anyone here? Anything similar to what just happened? Oh, we got some hands.
Nice.
Yeah.
So maybe this hasn't happened to you guys. Are you guys prepared to handle a situation like this right now? Maybe you guys are, maybe you guys aren't. But we're going to go into that today. So, hey guys, my name is Steven Braverman. I'm a DevOps manager over at Reach Local. I've been there for 3 months to this day, and my major role is to migrate us to AWS, doing it the right way. It's really hard to actually catch me on a bad day, so that wasn't real.
My name's Adam Keller. I am a platform architect at CloudPassage. We are a security company, and really passionate about DevOps, about automation. I like to say I live, breathe, eat, sleep DevOps, and I like to empower operations teams, development teams to blaze their own trails with no roadblocks. So that's a little bit about me.
Thanks for that intro, Adam. So today, we're really going to talk about a couple things, but the major goal we want to have for you guys is to understand why it's important to have a multi-environment Jenkins, why it's important that it's immutable, that it's disaster-proof, and then once we kind of discuss that, we're going to go into how you can set this up today, how you can achieve a multi-environment, disaster-proof Jenkins infrastructure using tools that we've actually created and are open sourcing. So a lot of you guys may not know this, but Jenkins is actually a really good chef. He makes some really high-quality food. And he travels all around the world doing this. So in order for him to prepare the best of food for you guys, he requires to have a certain set of tools that are always in a pristine state. So these tools include a barbecue. You know, you can't cook food unless you have some heat, and his barbecue has to be very perfect. Jenkins is very, very particular about his barbecues. Also, spatula. If you have a wobbly spatula, you're not going to be able to flip the burgers. You know, he also does vegetarian, so don't worry about that. Don't feel left out. And he also needs clean dishes. He can't provide to you high-quality food that's edible unless he has something to serve it in. So these are just a couple of the tools that Jenkins requires to provide you his quality food. And there's actually a lot more. But let's keep moving on. So a lot of you are probably aware that Jenkins isn't actually a cook. It's just a little metaphor we put together. And Jenkins, what he actually does is he provides high-quality automation for the devs and engineers to be able to perform continuous integration, continuous deployment, so that the business needs are met, and developers are happy and paid, and end of the day, everyone's happy. So Jenkins requires a certain set of tools to do this, and we're going to learn how it's important to set this up properly.
So as you witnessed, in our little skit there, there are many potential disasters that can happen in your Jenkins environment. One of which we just saw Steven do, which he went in, unknowingly just went and terminated my Jenkins master. Now, if I manually configured that server, if my Jenkins jobs were manually configured, I installed plugins manually, what do I do now? I'm in trouble. So that can really, really cause some big problems, some downtime. Now code's not being deployed. People are unhappy. Your product team is unhappy because the new feature is not going to be able to be released because Jenkins doesn't exist anymore. Some other disasters, I'm sure we all have kind of our war stories with Jenkins, but just plugins, plugin versioning. If you write some tooling, you write one of your jobs to talk to a very specific version of a very specific plugin, well, let's say someone goes in and updates that plugin. What happens? All of a sudden, your Jenkins job's not working, and you don't know why. So aside from that, it's just any type of manual changes in general. So imagine you have Jenkins jobs, they're all manually configured, someone deletes one. Someone deletes your most important Jenkins job that deploys your one repo that is your main application for the company, and that's gone. Again, this really could pose a serious problem, serious outage, and holds everyone back from actually getting the job done. So with
disasters. Yeah, so I just want to say really quickly, I just want to double check something actually. That's fine. We can go on to here.
Okay, so with that, we've taken this, our Jenkins environment, and we've kind of broken it up into three principles, into three kind of foundations. So one is the infrastructure piece. So when you look at the infrastructure, how are you building that infrastructure? How are you maintaining it? How are you updating it and making sure that that constantly remains in a state that you desire? Well, we treat our infrastructure as code. So the way we've built this environment is we've used a tool called Terraform, which I'm sure many people are familiar with. But this is how we manage our infrastructure. So there's no manual intervention. There's no manually doing anything in our AWS environment. This is all done through code. Also, if there's other options, there's CloudFormation, a lot of different ways to manage that infrastructure. The next piece is the Jenkins service itself. How do you manage that? How do you build that? The way we've done it is we actually use a Docker container. So we pre-bake a Jenkins, a Docker image that has all of the necessary configurations prior to startup. Not only that, the way we've automated a lot of the Jenkins configurations themselves is through Groovy. So if any of you have any experience with Groovy and Jenkins, the world is your oyster. There is so much that you can do to really customize and make Jenkins the way you want it to without having to manually go in and make changes. And last but not least, all these things are great, but how are you deploying the code? You have an awesome Jenkins environment, but then what? So the jobs. So we took advantage, and we like to take advantage of two very specific plugins. One is the Job DSL plugin, which just allows us to automatically create kind of our base configurations of our jobs. And then we use the pipeline workflow plugin to actually define the pipelines, how we're going to build, push, deploy this code into its respective environments. So kind of diving into the infrastructure piece. So as I mentioned, we use Terraform to build this environment, but this can be done using CloudFormation or any other type of tooling that you see fit. But what's really important to note is our entire infrastructure footprint is created through code. So that's everything from our secured VPC to defining our public load balancers, our private load balancers. In this particular case, we're using EC2 Container Service. So we are shipping a Jenkins image that is going to be run in EC2 container service. So this defines everything from our IAM roles, what's allowed to talk to what, and kind of all granularity, all in code. So just a very basic kind of infrastructure architectural overview. Super simple just for the demo. But you know, the Terraform code, what it's created is a Route 53 DNS record. So when you go into the Jenkins endpoint, it's automatically created in Route 53. Also, it's automatically synced with the public Elastic Load Balancer. So it would be very difficult to have to manually go in and constantly change if an instance goes away, you know, trying to add it to a load balancer or make changes. So we really take advantage of AWS's resources here. So just a very high-level overview of what that looks like.
All right, guys, let's dive deeper into our ECS clusters. So EC2 Container Service stands for ECS. There are a couple things that we need to assume will happen without us actually manually doing it. And these assumptions, let's go over them real quick. So in an autoscaling group, we have to ensure our desired capacity is at least 1 and more. So an instance, an EC2 instance, will come up. So as an instance comes up, it takes a couple minutes, takes a little time to provision up, make sure it's reachable, the network's working as expected. A couple tests AWS does. Another thing it does is we have to make sure that the instance, once it's up and healthy, that it attaches to the ECS cluster. The way we do that is using user data. And the user data was just a set of scripts, a set of steps that are taken once the instance is actually up and running, and the final processes of that instance coming up. So we have an instance, it's attached to the ECS cluster, and then we need the service to begin. So the service will take a task that we've defined, and that task is based off of a Docker file, either hosted on ECR or on Docker Hub. And this instance, it will run the container. So the service is the desired capacity for the service, and it'll be running on the instance. So those things are all assumed, and it's all part of the Terraform setup. So no manual intervention to get this little piece set up for you. And now let's hear a little bit about the Docker file.
Thanks, Stephen.
Yeah, no problem.
So, you know, I'm not sure, you know, who here has had experience with a Docker file or not. A Docker file, you know, whether you have or haven't. You know, a Docker file is kind of your base configuration definition for your container image, for your image that you're going to deploy as a container. So kind of how we work it is we have a base image, and did this get loud? The base image we pull from Jenkins. I'm a big fan of Alpine Linux. It's super lightweight. It's not heavy at all, and it's super easy to work with. So in this particular example, we're using the Jenkins official Docker image, and we're pointing to Alpine. And this is just some other kind of basic configurations, what user we want to run in the container, and then what ports we want to expose. As far as the container itself, when the image is being built, we're going to just install some very basic packages. So whatever packages you need, whatever requirements you have, it's all defined in your Docker file. So again, a big benefit here and something to note is if something goes wrong with my Jenkins master, I don't have to run a chef. I don't have to do a chef client run. I don't have to do an Ansible run. I don't have to do anything. All I have to do is kill my Docker file or kill my container running, and it's going to come back up exactly as we've defined in the Docker file with those files and that state. So just some more setup and configuration. So I mentioned earlier the way we've configured the Jenkins master in this environment is through Groovy scripts. So we have a set of Groovy automation scripts that we are going to populate into a staging directory in the Docker image. So these scripts will do things like configure the ECS slave plugin. So all of our slaves or agents in this environment are run using the ECS slave plugin. And then last but not least, I think it's really important to note is the plugin installation. So plugins are installed at container build time, at image build time. So this image is already pre-baked with your predefined plugin versions. It's all automated. All dependencies are downloaded. So there's no worry of, am I going to be in a different state? Am I going to get the wrong plugin the next time I start it up? And then last but not least, how is this container, what's going to happen when this container starts? So just a basic, the CMD command, which is going to run a series of commands that we've defined, which Stephen will jump into in a minute with our startup shell script. But the idea of the startup shell script is very simple. I want to pull down any dependencies that we can't really build or pre-bake into the container. For example, secrets. I don't want to bake my secrets into a Docker image. I'm just not a big fan of that, so I'd rather pull those secrets down after, once the container comes up, rather than just have it in a pre-baked image where anyone could pull that container down and run it. So then we run Nginx, and then we actually start the Jenkins service.
All right, time for the startup script. So this, really a few simple, quick little steps here, but essentially the idea here is we're setting up our container to be in a very bare, ready-to-go state. It's cleaning up, and the only thing that's not cleaned up are the jobs. So any job configurations from before, let's say we had a Jenkins infrastructure, it got blown up, now we're bringing up a new one. Well, this new one, we're going to keep the jobs that were in the previous Jenkins the same. So that's not changed. Everything else, the configs are replaced from the staging environment when the build happened and the container is running. And another couple things are we move the plugins. So we downloaded the plugins during the Docker build step. The container is running. So these plugins are somewhere in this container. So we need to move those plugins from where they are, the staging environment, and put it into the Jenkins home directory. That Jenkins will know where those plugins are, be able to use them as expected. Also, the Groovy startup scripts, we've talked about that a little bit. We're going to do a deeper dive in the next section, but those are important. So when Jenkins actually starts up, how is it defined? Those kind of things, like how is ECS defined, any master-slave executors, how your credentials, all that's there. And then we just clean it up and get ready to go. We set up the Nginx file, so we move that from staging, again, over to where the running container will be able to use Nginx. And now let's hear a little bit about the scripts.
Cool. Oh, so questions we'll take after. We're going to set some time aside. Thank you. So just one other thing I want to mention on the startup shell script is the job of this script is to just, you have everything in a staging path. It's all ready to go. But when you start your Jenkins environment, your Jenkins container, you're going to tell it where you want to mount a particular volume to, how you want it to, where you want things to go. So once we know at container startup what the volume path is, it's going to move everything to the Jenkins home directory, and everything then Jenkins takes over and does the needful. So now Jenkins is up. Okay, all the configs have been moved, startup shell scripts ran, secrets are there, we're ready to rock and roll. Really cool thing about Jenkins is they have their own kind of init system. So Jenkins has an init.groovy.d directory, which is where we place all these Groovy scripts. So when Jenkins comes up, I don't need any type of special automation to say, run this Groovy file, run this one. It's going to do it on its own. So it's very hands-off. The scripts are automatically there, and they're going to start running. So we've kind of placed them in numerical order. I do this because if there's any precedence, if I need something to run prior to the next, I just add the little numbers in front to make sure we know what's going on. But just a quick example, two that I'd really like to point out is the set cloud Groovy file. This automation actually, as I mentioned earlier, is going to create in the Jenkins master configuration, it's going to create that slave configuration. It's going to tell it what access keys it needs to spin up new slaves in that ECS cluster. It's going to tell it what environment I'm in. It's going to tell it the ARN for the ECS cluster. These are all things that are really important, and to have to manually go in every time and create that, it becomes tedious, and it's a real pain. So that's automatically done. And then I mentioned credentials earlier. So we have a credentials file that just stores some simple credentials, an SSH key, You can use the file credentials plugin, whatever you're feeling, you just throw them in here, you store them in the credentials domain, and when your Jenkins instance is up and running, we'll show you actually in a little bit, you can look, your credentials are there, and took no time.
Wow, Adam, so you're telling me that these steps right here allow us to be hands-off to completely allow our Jenkins infrastructure to come up automatically.
That's correct, Stephen.
That gets me every time. No more manual changes. Love it.
So, we've kind of talked about how we've done it. We've talked about the different tools. What are the benefits of this? So, by being able to have an infrastructure, to have an environment that self-heals, that auto-remediates, that if something goes wrong, it's going to take care of it on its own. That allows me, as an engineer, to continue to automate and make my platform better, to continue to bust out more features from my product as a developer. It really enhances just the overall workflow and makes everyone's lives easier. And now, as your traditional operations type environment, it's not like that anymore. This is done. This is all taken care of. You get to focus on doing the cool stuff. So that's one of the benefits.
Another is the volume. So EBS volume actually holds the jobs information, a lot of the Jenkins home directory. So what happens is when our EC2 instance within our autoscaling group, which is attached to the ECS cluster, as we talked about earlier, when that instance provisions up, the user data, what it also does is it seeks out and finds the EBS volume that's managed by Terraform. So there's one volume that we manage, and whenever an infrastructure goes down, Jenkins infrastructure dies off, a new one comes up in place, that Jenkins master will be using that same exact volume. And that's where all the jobs are stored. So that's how we can quickly come back from a state where we have nothing, and now we have everything set up.
And even worst case scenario on that, let's just say your job history's gone. Let's say something happens to that EBS volume, someone deletes it. Okay, so you lose job history. But again, everything's managed as code. So to rebuild this, you have a new EBS volume, your job history may be gone, but all your jobs will be back because we're using the job DSL plugin, we're using the pipeline plugin. So everything's automated. You're not worrying about what happens in the worst case. It's all thought through and taken care of. And then, lastly, I know we tend to, I feel like we're repeating ourselves, but it's super important to mention that the Jenkins master self-configures. What does this mean? This means that I'm not doing anything. I'm not having to set up anything. I'm not having to go into the Jenkins UI, go to configure, change some settings, install plugins. I don't have to do any of that. It's all automatically done and handled every time the container comes up.
All right, so I'd just like to point out real quick, so with these benefits, whenever you want to apply new changes to your current infrastructure, there's no need to create a brand new infrastructure. You can if you like, but it's not necessary. A lot of these changes, all these changes actually are designed to run in place. So if you want to add new infrastructure, maybe change how many instances your ECS cluster will have or ASG will have, that's done. You create a pull request, merge it in. It'll apply it to the currently running infrastructure in a safe way. And then also if you want to change a job, again, you don't have to create a brand new infrastructure. It can happen in place. But if something were to happen and you need to create a new infrastructure, it'll come up looking as the last version control state. So it's really important to note that you don't have to create a new infrastructure, but you can roll it out in place. So we've been talking a lot about benefits, and you guys might be thinking that, sure, it sounds really good, but what are the hidden sort of not so good things? Are you guys going to talk about that? And of course, with anything, with any good, there comes some bad. You have to outweigh what the benefits are with what the negatives are and the shortcomings. So a shortcoming here is now that we're providing Jenkins as a service, as a product to our engineers and developers, that means we're applying changes quicker. And it also means that not only we as potential DevOps engineers or ops guys, or also the developers themselves are creating pull requests and making constant changes to our Jenkins infrastructure, Jenkins as a service, and the jobs. So this means is as we apply changes quickly, we're going to break things quickly. And so that's something you have to take into consideration.
It's a great point. And I think that's like a double-edged sword, because now those barriers, those walls of who manages what Jenkins job and who can create a Jenkins job, those are gone because a Jenkins job is in code. So if you're a developer, you don't have to wait on an operations guy. You don't have to create a ticket, wait, a week because he's busy. He's, checking logs. The elk stack's down. He's trying to figure out what's going on. You don't have to worry about that. You create a pull request, someone reviews it, it's merged, and you're in. But with that said, this changes the workflow a little bit now. So there is no more manual configuration. There's no more someone going in and making changes. So this requires code review. So you may have to wait now. Instead of having the ability to go in and change things manually, you're going to have to wait for someone to review your code. They may not like it. They may tell you to make changes, and you're going to have to go back and fix and iterate through until you get the right changes. So this can slow things down a little bit. But I think as you kind of work through your operational processes and you speed it up, it technically becomes less of a shortcoming and more of a benefit. But I definitely think in the beginning there can be some pains associated with that.
So what can we do to mitigate these shortcomings? Let's go back and think about Jenkins as a cook again. So in the beginning, we talked about Jenkins. He has to provide quality food. And in order to do that, he needs these tools. So now we've created these tools to come up and be immutable. So his barbecue, let's say it blows up all of a sudden. Well, Amazon drone is going to come by, drop off a new one within minutes. And he's good to go. He's back to cooking, right? Let's say a spatula just like shatters into a million pieces. Same thing, new one will come up. Say dishes are dirty, just go ahead and break them. You get a new set of dishes within minutes. Great service. Now, what if this is constantly happening? What if someone merged something and it's constantly breaking, and you have a production deploy that has to go out in a couple minutes, and 20 minutes ago, a developer merged something. It went through the code review, went through the plus ones, but it didn't catch, not everything was caught, and it's breaking your production deploy that's happening right now. Your infrastructure is constantly coming up and down, and you're just in a state of chaos. So what we can do is actually set up a QA and a production Jenkins environment. So I know a lot of you probably already potentially do this. I know some of you split up your Jenkins into different teams, so different organizations, different teams have their own Jenkins. But what if we split that up a second way? So we have a QA Jenkins, which only manages the QA jobs, and then a production Jenkins, which only manages the production jobs. Just kind of think about that for a second. And let's talk about that. Let's talk that through now.
Yeah, so I mean, this is a really cool idea and a cool concept. So, by splitting up your environments, first of all, to do this, it's just a button click. I have a prod environment. I'm going to change my environment name, the stack name, whatever you want to call it, and I'm going to hit a Terraform apply. And Terraform's going to build that environment. And now I have a separation of two environments, and I can point my QA environment to kind of like a release next branch, a develop branch, something that's just the latest, bleeding edge code changes. And, developers, DevOps, everyone could just go start, submitting pull requests, merging code, having it go live. And those changes, if something goes wrong, that's okay. You're breaking QA. Now that developer or that development team that needs to deploy that code, they don't have to worry about someone coming in and submitting a pull request, that getting merged and breaking things. Of course, anything can happen, but now you have one extra layer of protection in an environment where you can get a real, true test because they're an exact mirror of each other. These environments are an exact mirror. So you vet changes from QA or development before they make it to your production Jenkins environment. Also, your development Jenkins is less restrictive. What does that mean? You're pointing to a later code base, a code base that has, like I said, more the latest features. You have more flexibility. You don't have to, close things off. You can be a little more open. Let more people get into Jenkins. If you want to open it up and even let people manually go in and make changes to test things, you can do that. Because again, this is a development environment, and if someone breaks something that's catastrophic, okay, just get rid of it. It'll come back up. It'll be fine. And last but not least, this is probably one of my favorite things. The security guys love this. I know security guys at my company love this. Prod Jenkins is locked down. And when I say locked down, I mean there's not one person that has admin access to production Jenkins. That may seem crazy, but why? Why do you need it now? You don't, because your Jenkins environment is all managed by code. If someone needs to make a change, it's going to be vetted. It's going to be tested in QA or development environment. And then by the time it makes it to production, you know you're in the best state that you can possibly be. So very happy. I love that.
And a great thing just to note, just to instill the idea, now that Dev Jenkins is less restrictive, so that means developers are going in, kind of making changes on the spot, on the fly, but Jenkins will actually automatically clean itself out, so it's in the last stable version, latest version controlled portion of it. And this really instills the developers to actually go through the pull request process and make changes, because otherwise their change won't go into production. And that's honestly where we need to get to. So it instills that practice of code necessary to move forward. So great news, guys. Open source is coming soon. By the end of this conference, there will be a link for this. There should be ways you guys can reach out to us, but we'll be here the next couple days. But we will have a link available. You guys can start using these tools immediately.
Yeah.
And yeah, we just want to say thank you to you guys. We appreciate you waking up early, coming here after breakfast. I know it's just about lunchtime. We talked a little bit about food. Your stomachs might have been grumbling. I think I heard a little bit over here. But yeah, we would love to hear any feedback you guys have, any and all. Our ears are wide open. It took me a long time to get this bow tie on this puppy, so
poor guy.
Appreciate any feedback you guys have.
Yeah, and I just want to say, thank you again. If anyone has any questions, afterwards we're going to be around. We'd love to talk. We love to talk DevOps. We love to talk automation, continuous integration, continuous deployment. It's so much fun. I love to hear people's stories, what you're doing, because there's a good chance you're doing it better than I am, and that's what's so cool about conferences like this. So really appreciate you guys coming and being here. So thank you.
Thanks, guys.
So how do we do questions? Do we do like a mic or something, or just yell? I think we're close enough.
We'll just repeat the question.
Okay.
Just repeat the questions. Thank you.
Okay, so have you explored GitHub SCM sync plugins?
The SCM sync plugin. Are you talking?
So that reserves every state change being made on Jenkins master onto a GitHub repository. It's a complete audit log of who did what, when.
Oh, that's cool.
You can restore it back when Jenkins disappears.
That's very cool. Yeah, so and that's I think that's awesome. So you want to repeat?
Question.
Go ahead, repeat it.
Okay, so the question, the plugin name was the sync SCM,
Sync plugin.
the Git SCM sync plugin.
Yeah, the GitHub SCM
The
sync
question
plugin.
is if we've looked into it. And honestly, there are so many different tools out there that can help you with this. There's so many ways to do it. The way we do it might not be the way you've done it. So that sounds like a great tool to use to sync up your
That's awesome.
version.
Thank you. She had.
Two questions. Will you share slides and or video of this presentation?
So question one, will we be sharing the slides of this presentation? Absolutely. We will definitely be sharing it with the good people of Jenkins and CloudBees, and
I believe
we'll
they're
find
going
a
to
way.
YouTube it, right? I believe this.
Yeah, I think we're getting filmed as well, so I think that'll be out as well. Was that your second question?
No.
Okay.
My second question is, when you say open source, do you mean like the Docker files? Or?
Yeah.
So the question is, what do we mean by open source? So open source means everything you've seen here, the code snippets, anything and everything necessary to bring up that demo Jenkins that we showed you is going to be visible, and you'll be able to clone, to fork, and to contribute to as you please.
And so just to elaborate a little bit, so that's going to include Terraform configs. So it's a very simple process. It's a make file. A lot of people with Terraform, it's very common to just manage that in a make file. So it'll be as simple as just running like a make apply, make plan, so you can see your plan, and then the Docker file and everything else will be open source as well.
And I'm planning to add also CloudFormation Troposphere, just so the options are available. So that's coming as well. I'm not guaranteeing it by the end of the conference, but
It'll be there. Okay. Oh my gosh, so many questions.
Will you open source your setup or a simplified setup?
It's going to be, so he's asking when we open source, is it going to be our setup or a simplified setup? So it's going to be a very generic setup. So the way it'll be open sourced is everything will be super generic, and you could, really all you need to get this up and running is there's just some variables you'll override. There's a simple overrides file. So stack name, for example, the name of your environment, what that's going to look like in AWS. Also, but yeah, it's going to be super generic.
So there'll be like a config file where you attach the list of plugins you want to use, and that list will get used when it's time to download the plugins. Any settings you want to override, as Adam mentioned, will be configurable through a config file.
Okay, how does it look like with the Groovy scripts for like configuring Jenkins? Because this is somehow not. How are you able to make this generic? It seems it is impossible to like generalize this.
So
I can tell you one example that you can look at today. Earlier in the keynote, Accenture has a.Jenkins. It's Docker files and Groovy plugins that are already open source that you can sort of take a look at.
So imagine,
answer the question, or repeat the question.
yeah, go ahead.
So the question was, how are these Groovy scripts actually made in a generic way? So these Groovy scripts that actually change Jenkins as a service. So Jenkins comes up, for example, the credentials plugin. Right? We need the credentials plugin to hold all of our necessary sensitive data, as well as apply changes to AWS as necessary. So what we can do is we can set up a config file that you pass in the necessary credentials you want it to have. And then when it's time to run, when Jenkins comes up, the init comes in, and using a loop, it'll just pull in all your configs and push up.
But even more specific, so like the ECS slave plugin, for example, how we configure that. AWS, if you have experience, if you don't, AWS has a metadata endpoint. So this is where we get things like region, account number. This is how, in the Groovy automation, we're actually dynamically getting a lot of these things. So a lot of these values are just dynamically populated. And the ones that are not, we have wrappers, basically wrapper functions that will grab certain values and then populate based off of a config file that you've set, certain values. So, who else? Who else? You pick. I've picked.
Set your hand for a while.
You mentioned managing the jobs as code and opening that with code review. Does that mean people are doing code review on the config.xml content of a job? Is that what you're checking in?
So that's a really good question. The question is, we spoke a little bit about code reviewing jobs, so jobs as code. And the question is more specifically if we're actually looking at config.xml files. So that is one way to do it. The way we've opted is more of a programmatic way, so using Groovy, using the job DSL plugin, which allows you to create jobs using Groovy, and also Pipeline, which is a nice language that you can use, easier to read, and that way you can create jobs that way, more programmatically.
So a follow-up. So the developers working on the dev instance, when they're doing their job development, they're using this job DSL plugin.
Yes. So the question just kind of went forwards, asking, are the developers using this job DSL plugin? And yes. So it's a two-part. So one, the Jenkins pipeline plugin. What my favorite thing about this plugin is you have a Jenkins file, which is a definition of your pipeline. But guess what? That doesn't live in a generic repo. That doesn't live in my repo. That lives in the repo of the developers, their code base. So whatever their code base is, if they need to make changes to their pipeline, how they're deploying, if they need to source a new end variable, whatever that is, that's in their code review, and they make sure that goes through. Now, on the inverse, we have the job DSL plugin, which is centralized one place, but that's just creating your base shell jobs. It's just a very basic definition, so that rarely gets changed. That's just saying, I have this application, I need to point it to this application repo. So.
Groovy side of it can be very, very difficult to sort of figure out how to automate pieces. Do you have suggestions on resources, or how did you manage this?
I love this question.
It can take forever to say, figure out how to configure GitLab or things like that.
So the question was, just working with Groovy, it can be very, very, it can get confusing, and it can be challenging. I need tips and tricks, or how do we do that? So I want to touch on that first. It can be. It can be very challenging. And this is the one thing with Jenkins plugins especially. If you update a plugin, all of a sudden, everything you've written in Groovy, they don't always write things backwards compatible, and now all of a sudden my automation's broken. So it's very important, A, to pin plugin versions, because I've been bitten by that many, many, many times. So resources, typically my workflow is, first of all, the internet is just amazing. I'm always able to find something that's going to help get me in the right direction. It's not always going to be exactly what I want, but it's going to help me. I typically will go to the plugin I'm working with. I'm going to go to the GitHub repo. I'm just going to start reading through the code. And I got to tell you, so reading through their tests, oftentimes reading through their unit tests are going to make things easier. And I can see how they're instantiating objects, how they're doing it, and that helps me. But yeah, I mean, it's not easy. There are times I've spent days, weeks, and I've struggled, and I know the feeling, it's funny. It's normal. It's so funny. That's so funny to hear. But there are pains with it. But I swear to you, that end result, once you get it and it's tight, it's amazing. And then the first time I did it, it was crazy. But then as I kind of found a workflow, read the code, look online for examples, I was able to kind of marry the two together, and it made it much easier, and I was able to iterate much faster.
Yes. All right, so the question is, so this setup allows to bring up infrastructure, allows you to have everything set up as far as your pipeline goes and your jobs as configuration and Jenkins as configuration. But what if your jobs currently aren't in that state, that they're programmatically created using Groovy or pipeline?
And
so
just a little more to that. But also another really important thing is, how do you get this to the developers, and how do you get them to start using it, right?
So honestly, there's a couple different ways to go. A big way I've found that really works is show. Like do it yourself, show how it works, and then start locking down Jenkins and show, hey guys, like I know this is the way we've been doing it, but look at what I've done. Do a little show and tell, knowledge transfer, start getting the teams together, kind of plant the seed into their head that this can be done in a better way. And do you have some more?
I do. I love this one because
Yeah.
this was when I started at my company. This was a very real situation for me, and I can empathize and relate to this exact situation. So, as Steven said, I think showing is great, and showing by example, showing them how it's done. But really, the way I paired that with actually infiltrating their repositories, and I threw a Jenkins file in there. And first thing that does is that sparks questions like, what is this? Why are you submitting a pull request with this file? What does this mean? And that's my opportunity to get in and explain. And I've just always found in these organizations, in technology organizations, it's hard. DevOps, kind of a DevOps transformation, this idea of not manually doing things, it's not always easy. And there are so many challenges that come with it. And there's a lot of roadblocks. So for me, it was this infiltration. I would talk to developers, I would evangelize, and I would find, maybe out of 100 developers, I had 2 that were in, and those became my champions. And I used them to help me champion the change. And we did. And now, what's amazing is we went a year ago, when I started, from Jenkins jobs that were all manually configured. You went in, it was like, it was a nightmare to not one job is manually configured now, not one. And all of our developers are on board.
It's a really great point about the infiltration, to show them what you need to do. But also, once you find these champions, once you find these guys that are into it and they get it, then you can start doing shuffles. You can bring 1 or 2 of those guys in per team, per a couple sprints. Let them see how it is you're doing things. Let them get right in there. Make sure that they're focused on what it is you're doing. And a lot of companies do this. I know the past couple of companies I've been at, really big in shuffling. And that honestly really helps, because then those engineers come back to their team and they start doing things a little differently. Maybe they're not using exactly everything that we were doing on, let's say, like a DevOps style team, but they know what's out there and they want to start doing those things as well. And they can share their knowledge they've gained with the team and continue forward in a better practice.
That's an awesome question. Thank you. I don't want to leave you behind.
Yes, we're out of time. Do we have time for one more question? Yeah? Okay, so the question.
Sorry, at the end we discovered that we are doing exactly the opposite that you do. We give permissions to everyone because we know that in any moment we can recreate any transaction. Does it make sense?
Yeah, so the last part, let me just make sure I understand the question. The question is, so we split up Jenkins into environments. We have the QA portion and the production portion. How long does it take for changes that are merged to QA to actually get to production? Is it a long time? Is it a short time? And the last part was asking, or is that the, okay. So, I mean, there's a couple ways to do this. If you're comfortable with moving in a CD fashion, then changes that go in, if you have any sort of testing created around it, you can then go ahead and get it bedded directly in. It depends on your bedding process. If you want your changes to be managed or tested by QA engineers, and you want it to be signed off in a cab, and it has to have certain approvers that go in, that can go in that way. If you rely on CD and you've set up a really good testing infrastructure, you can have it be right away. It can go into QA, the test will run, maybe it just requires one approver, and then you can automate it directly into CD. But the idea is really that you only want these bedded changes to go in. So it really depends on how much you're willing to sacrifice, how much testing you really care about before it goes to production. Because if you need to get a critical change in right now in production, and your job's not working because someone merged something, it wasn't tested completely, and it went directly to the production job, then it's not going to work, and people are not going to be happy. You're going to have a terrible day. So we really want you to have an awesome day every day.
Yeah.
So that's,
and I just think, I think managing access in Jenkins or even having it wide open, I mean, there's a lot of value to that, but it's so easy when you have permissions wide open. It's so easy for someone to make a change to something that you just don't catch. And things are going as you would think are normal, but all of a sudden, someone changed a new relic key in your credential store, and you didn't realize it, but for the past 7 days, you have no data being sent to New Relic, and you didn't know that. So it's things like that. So I prefer to just take the end of, if you want to do anything, please submit a pull request, submit a merge request. Let's do this, but let's not manually do it. Let's do it as code. Let's stick with that, and it's not always the easiest, but I think at the end of the day, it's probably the safest.
it's really hard to make manual things very transparent. When it's code and you know exactly what it looks like, because you can open up whatever version control you're using and you see exactly what's there, what else do you need? You don't need to know anything changed manually.
So I think
all really
that's
good
it.
questions.
Yeah, thank you guys so much. Appreciate it. Thank you.